Good morning or good afternoon, everyone. Thank you for joining us today to this P1 webinar. We'll be talking a lot about P1 electronics within this webinar, and hopefully some of you have followed many of our webinars in the past 2 or 3 weeks. They've been greatly put in work by the famous Scott Sugden that all of you have seen on TV right by now, I think. With me today, introducing P1, I have a lot of good colleagues who will be able to answer many of your questions, whether they're French questions, English questions, Russian. I think we have German questions. We even have American questions if you want to, Spanish as well. So let's introduce some of my colleagues today here. Very glad to be with them. Starting with French. After all, we're a French company. So hi, Mark. How are you today?
Hello, hello.
That again. Hello, Mark.
Bonjour. Yeah. Hi, Germain. I'm fine, thank you. I'm glad to participate to this webinar, and I will try to answer your questions into the chat. So, vous pouvez poser vos questions en français, aucun problème, et j'essaierai d'y répondre dès que possible. Merci à tous.
That's right. Thank you so much, Mark, for being with us today. I'm in the usual suspects, Sergey, who will be able to answer great questions in English as well as in Russians, and I believe about 46 other languages. I think somewhere around that. Hey, Sergey.
Hello, everyone. 46 is a bit of an over exaggeration. 45 is the right answer, but it's a joke. And it's again sun shining in London for the 3rd day in a row. And enjoy the webinar. Привет всем. Задавайте вопросы на русском, если хотите на английском. Наслаждайтесь.
Thanks, Sergey. So as you guys must have heard, we definitely are in very strange times. It's been sunny 3 days in a row in London, so definitely strange times. Let's get over to another on the side countries. Martin, how are you from Germany?
I'm very well. It's sunny since 3 days at least, and I think we are reaching nearly 20 degrees today, so summer is slowly coming. And I'm happy to be here, and I'm also happy to answer questions in German. Wer also Fragen hat auf Deutsch, kann sie gerne auch auf Deutsch stellen. Bin hier in dem Chat für euch da und ja, stehe für alle Fragen zur Verfügung. So thanks a lot.
Thanks, Martin. So let's cross the Atlantic a bit and see what do we have over the ocean. Dan, how are you with us today?
Yes, how's it going? Coming to you from Milwaukee, Wisconsin, where it is sunny out and not warm, let's put it that way. We're in the single-digit Celsius still in the mornings and getting there, but definitely welcome everybody to the webinar and look forward to trying to answer the questions as we go through.
Super. Thank you, Dan. It's really cool to have you with us today. And jumping south a little bit from where you are, we have Alex. Alex, ¿cómo estás?
Oh, muy bien. Gracias, German. Thank you, guys. Really happy to be here again on these webinars. It's a beautiful day in Mexico again, so it's a good day for an interesting webinar. Buenas tardes, España. Buenos días, Latinoamérica. Bienvenidos a este webinario del día de hoy. Aquí estaremos para atender sus preguntas en español. Thank you, German.
Super. Thanks, Alex. Producing with us today, we'll have Guillaume. A lot of you have met Guillaume during the past webinars as well, answering either questions or producing this webinar. So thank you again, Guillaume, for being the man behind the camera, if we can say. But I'll not be completely alone presenting this great P1 presentation and introducing all those new features that you all are keen to learn about. I have the great and the only Tony Zabo with me today, also presenting. Hi, Tony.
Hi, Germain. Thank you very much. I thought you were about to say we have the great Scott Sugden, because we have him as well. But thank you for that. And I'll do some English Q&A, but I'll also be up here doing the Australian ones as well. So thank you.
covering pretty much the entire Earth with all our team. That's really cool. But it's true, we also have the great and the only. I mean, there's only one of a kind Scott Sugden in the world, and I think we're pretty much okay with that. We're kind of lucky to have him with us, I must say. Hey, Scott, how are you?
I owe everyone a beer because I forgot my microphone. I apologize for that, guys. Germain, I'm doing great. Thank you for having me today. Once again, I'll help out and answer as many questions as I can about the P1 and the whole ecosystem that surrounds it. And I think I'll help you present a few points at the end as well. So thank you for having me, Germain, and we'll talk to you soon.
Thank you, Scott. All right, so as my colleagues say, you have a chat platform to the side, so don't hesitate to ask your questions, write your questions down, and we'll make sure to answer most of them, if not all of them. So, okay, let's get onto our precise subject today. Focus of today will be P1, our electronic platform that serves as an AVB processor and measurement platform, but actually not only. P1 is very a multitasking solution that really takes us from the front-end processor, as well as a bridging audiometrics, as well as a system tuning platform. So it's kind of a three-in-one solution to really help you streamlining all your design of all your ecosystem of L-Acoustics, and that's why we call it a little bit the gateway to the L-Acoustic system. It's kind of the first door, so it's the entrance gate to an L-Acoustics ecosystem. Within a small 1U enclosed boxes, you really have something that helps you with audio quality, that improves the audio quality throughout your entire system, that really helps you in streamlining your signal distribution, whether it's from on AVB, AES, or analog. It also helps you distributing audio and control through your network. It also helps you through your measurement process of your network. Obviously, we'll go over in details into each of these three pillars of the P1, but let's see where it sits a little bit in our ecosystem. So we say it's a front door, so it's basically where most of the time, in most of the cases, it's going to sit in between the console and the amplified controller. It's going to take in charge all the signal distribution, whether we're talking about control or audio. We'll see about that a little bit later. And in the ID behind P1 is really to make everything so simple and also reliable. So we want to make sure that everything sounds the same from one day to the next, from 1 gig to the next, or from one place in the world to the next. That's always the philosophy behind the ecosystem of L-Acoustics. So we're saying that it can sit right before the console and in between the console and the amplified controller. So typically we'll sit at front of house, but it can also be located elsewhere in our system, close to specific amplified controllers, distributing analog or AES for non-AVB amplified controllers. Could be installed in the amplifier control room for a fixed permanent installation. It serves kind of many purposes. And to kind of help us understanding what are these purposes, we'll take one example of deployment for today. We'll focus on one of a large type arena system, festival system, something that has a main hang of the system, outfields, front fields, subwoofers, infields, all kind of loudspeakers that serves different purposes. The goal behind this is really to maintain that philosophy of ecosystem, to make sure, once again, that everything is controlled and defined through the same control platform. And here we're talking about LA Network Manager. Everything is P1 is integrated seamlessly with all the controls and monitoring within LA Network Manager, in the idea to always increase consistency, as I say, but also predictability. We want to know exactly how our system will sound, how it will behave in any location, in any deployment. Whether it's a small system, we'll be talking about very small deployment of system, or we will be talking about very large deployment of systems. And the idea, again, from P1 is to kind of streamline the process all the way from implementation through calibration, but also live operation. So let's see how we will interact that into our system. So with me, Tony, that I introduced a little earlier, will be presenting the system in the view of, in the very applicative view, as well as the within LA Network Manager. So we have this system with us today, which is composed of K1 as a main system, K2 outfields, we have KS28 as subwoofers, we have a set of front fields with us, and we have a set of infields that's located on each side of the stage. All this powered through LRAC2 AVBs and one LRAC first iteration of the name that will power the infields and the front fields. So let's try to remember a bit that picture. We'll be seeing this a bit more later in the presentation as we build our system, basically. All right, so P1, it's a 3-product in one. It's a network digital audio processor and 3 facets, but the first one is kind of the most, I guess, straightforward, the one that directly comes to mind, but is nonetheless one of the most important, especially for today, because we are introducing P1 with a bit of a boosted capability, if I can say. We introduced P1 a couple of years ago, and we presented P1 with a 20 inputs platform that could go through 4 DSP buses and exit through 16 outputs. Well, right now we're pretty much happy to say that we've managed to boost and really offer a doubling capacity for DSP on P1 and offer 8 DSP buses instead of the 4. So that's a very big improvement. We're very glad to be able to offer that very soon to you. So still have the 20 inputs and with a little bit of a improved gift here as well, going through an 8 DSP buses matrix mixer, exiting through 16 outputs on different formats, and reaching the amplified controllers through either AVB, AES, and analog. But what's very important here to look at as a big picture for all our system is that regardless of the output format that you're sending to the amplified controllers, everything will be, all signals will be time aligned, not only time aligned, but also level aligned. So you want to make sure that at the exit of the amplified controllers, what you play to what you will produce to the loudspeakers, all will be exactly on time. And that's extremely important. In the case you have a little failure in one of your format of your cables, you have a failure on the network, you have for AVB, you have a failure on the ES cable, and you want it to fall back to analog, you want to make sure that every single loudspeaker in your loudspeaker array will receive the same signal on time. So that's one very important feature of the P1, and it means that regardless the situation, if you enable the fallback option, then you will always get your reliability and performance that you expect from an L-Acoustic system. But let's get into a bit more details into each of these 3 sections. Inputs first. So on the side of the inputs, we have, looking at the front panel of the P1 that you can see on the bottom of the slides, we have 4 mic inputs with a switchable 48-volt phantom power and a high-pass filter. So you can see directly the inputs from the front panel of the P1 right there, and accessible directly in terms of managing the switchable phantom power through LA Network Manager.
Yeah, and Jamal, so basically we've got, it's a mic line input. So on the front panel of the P1, we actually call it a mic input, but we can double up and use it as a line input as well. And we can access the gain. We can get up to 60 dB of gain in 3 dB steps. And where we access that on Network Manager, we can also access the high pass filter, which is a brilliant thing.
Yeah, exactly. And actually, stepping up onto what you just said, these microphone inputs have extremely high performance microphone preamps. So we are really here looking at a high performing system that really takes the best of every single part of the chain of the audio chain. Sorry. So some of more inputs, we have analog inputs. We're looking now at the rear panel of the P1. We have 4 analog line inputs. Once again, we have premium components, very high performance components for conversion, whether it's from A to D or D to A, very high performing components in there. We want to do always make sure that we get the best audio quality we can, even using AES and even using analog. For AES EBU inputs, high quality sampling rates, all converted to 96 kilohertz. All will be treated at 96 kilohertz within our system. So very high performing upsampling if we are getting into the P1 with a lower sampling frequency. So that's the 4 channel of AES.
And Jamal, the good thing here is that those are on XLR connectors on the back panel. So as you can see from the bottom of the screen there, we've got XLR in and out for analog as well as for AES. Makes it a lot easier for patching that in and out.
Yes, exactly. And actually independent connectors should we add to that. All right, and the great thing also, which is one of the core reason of building a P1 as well, is to welcome AVB within our ecosystem. So AVB P1 once again has been quite improved, and you will have that version very soon. And it's now capable of listening to 2 independent streams. And from those 2 independent AVB streams, it can retrieve up to 8 channels, 8 AVB channels. We were able to do that from 1 AVB stream only, and we now have the possibility to do that and to listen to 2 independent AVB streams. We'll greatly simplify in terms if we have a couple of consoles, couple of source signals, 2 independent source signals, for instance, sending AVBs. It's a very great addition to the P1 lately. So from the AVB streams, not only do we receive audio, and we will be able to send control as well, we are also receiving a clock stream. So it's called a CRF stream, a clock reference format stream, and this is what will define our master media clock and synchronize all our network on it. We can decide to receive it from an exterior device, or we can decide to use P1 as the reference device for the master media clock. And as a little addition that you actually could have seen from the front panel, we have a media player USB socket that you can will welcome be used for a media player. You'll be able to play WAV files, IAF, FLAC, or Apple lossless. This actually the media player, when it's enabled, is taking 2 channels of the AVB streams, and you'll be able to connect it to any of the outputs that you require. Couple of GPI, we are on the input side, a couple of GPIs via a DB9 final connector that you can see on the right hand side here, and that you're able to control mute state, or state use or configuration, or load any kind of other configurations you may require. So let's have a look at next.
Well, while you're still on the inputs there, I wouldn't mind just pointing out that we can use the AVB as an input on the P1 if we had an AVB console, but we can then also have AES as a fallback for that console, and we can also fall back to analog. So we can treat one as falling back to the other, or we can treat them as 3 separate consoles if we wanted, or multiple consoles. So we've got different ways of using those inputs.
Exactly. So once again, providing even more features for true reliability of the system. You are able to fall back the inputs onto, and you can change that. You can even do a AVB fallback to AES fallback to analog if you really wanted to do ceinture et bretelle, as we say in France. All right, so let's have a look at the output side this time. So we were talking about 16 outputs. So it's in the form of 4 analog line outputs, once again with premium components in terms of DA conversions. From the analog, we have the direct XLR output from the rear panel of P1. We have 4 AES EBU outputs clocked at 96 kHz, but can be also used at 48 kHz with a high-performing downsampler. AVB. P1 is an AVB talker. So in terms of AVB devices, it means that P1 is capable of sending an AVB stream, and P1 is actually capable of sending 2 independent AVB streams with a maximum of 8 audio channels. So basically, it could be 2 independent AVB streams, but as we will see later on, it could be the exact same streams. It could be an image or a copy of the exact same stream in case of redundancy from the Milan protocol. But we'll be talking about that a little a bit more afterwards. There's also a stereo headphone output. It's actually quite a powerful headphone amplifier, so that you can use low impedance headphones with this headphone output if you want to. And a couple of general purpose outputs, GPOs, that you can use to monitor the status of some operations on P1. And once again, as Tony mentioned, for the inputs, you can decide to, at the amplifier stage, choose to have a fallback option. If the amplifier does not receive correctly the AES signal, then it can fall back to analog. Or you can choose to have a stream of AVB, choose as your primary stream coming in AVB, and then if something happens on the AVB streams, you can fall back to AES and analog, keeping always everything time aligned and level aligned. This is actually the worst thing that could happen. Imagine if you had a like a fallback system, but with different timing structure and different gain structure. It means that potentially within one single line array of speakers, some of the speakers would not be time aligned. And this is exactly the worst thing that could happen within a line array of speakers.
Yeah,
this is
exactly
what we want to counterbalance.
I'm glad you brought that one up, because it could be that a connection on the back of just one amplifier, the network connection's a bit funky, and you could fall back to the AES input. That's your fallback that you've patched in. But if they're not time aligned, then in the middle of your K2 array, the 2 speakers you're plugged into, those 2 speakers could be a couple of milliseconds difference. So that is going to just collapse everything there. We need everything to be perfectly time aligned, and that's what we've done. So I'm really glad you pointed that one out.
Yeah, and that's actually quite, it's a simple automatic tool that's embedded into P1. So there's nothing you have to do. It's all P1 calculates automatically all the timing required for all of these formats, output formats, and does the math itself. All right, so what happens between the inputs and the outputs? Well, we have a matrix mixer, and we have a matrix mixer of 8 DSP buses, a matrix mixer 2D 8 DSP buses, excuse me. And that's very important. That's really the big, and very proud of the big improvement on P1. We kind of unleashed the power of the second core of the P1 to get 4 additional DSP buses, and bringing you much more flexibility into this exact same chassis that you had before. So this actually requires only a firmware update, and you will have the 8 DSP buses that you will see into LA Network Manager. So as I pointed out earlier, all this is configured, all what I'm talking about is configured through LA Network Manager, and we'll see actually Tony going through each steps of the process of configuring a P1. So 8 independent buses fed by a matrix mixer. You can actually route any input to either directly to any output, but also any input going through any of the DSP buses, and then going to any of the 16 outputs that we have. there is actually a Q bus actually routable to any physical outputs that you want to use. So you could use it to isolate one or several inputs, either in PFL or some of the buses in AFL if you want. So it could be used as a monitor with headphones.
Yeah, exactly, Jamal. That's a great one. I mean, that's a big one that a lot of us try to use live. And we've got a couple of monitor speakers at front of house, you know, and you'll want to put your Q bus through those monitor speakers. And so you could patch the output of the Q bus into 2 analog XLRs in the back of the P1, and then you could plug that into your powered monitors, and then you've got that front of house. And not only that, but we've also got a delay available in that Q bus, so we can time align those speakers at front of house to actually your K2 that's hitting you right in the face there. So everything's time aligned and we're all good to go.
Yeah, actually the delay is I believe is up to 2 seconds. So actually it's quite a long distance between FOH and main system before you're reaching the 2 seconds of delay needed, I guess. So within those independent buses, we have tons of capacity. We can do on each individual buses, we can do gain, we can do delay up to 4 seconds. We can actually trigger mute statuses, change polarity. Each of these DSP buses has 16 IR EQ filters and a bit of dynamic processing to secure all our systems. Something that will open up more possibilities later on, but that's already here to help us managing and getting our system correct right at the beginning. All right, so Tony, if you have nothing less to add, let's try to take a step through our system that we just saw before. And that was our K1 main system, K2 how it feels with our couple of L racks. Do you want to take us through that, following the schemes we just discussed?
Yeah, okay, we'll go forward. First of all, I'm sorry, I thought this was K2 and Kara, so my network manager file is based on K2 and Kara there. So we've taken these amps and these speakers out of the truck. We've got our console and we want to patch it all in. So we're going to add a P1 at front of house. We have a look at the next slide and we're going to patch that in. The blue lines there showing the AES connection from the console to the P1, and then we've decided we want to have a backup signal as well, so we'll put the analog there as well. So left, right, sub left, sub right, they're our console outputs, and then we'll go to the next. We're going to get those outputs of the P1 down to the amplifiers at stage with analog and AVB as well. So that's what our system will be, and I think, are we ready to hand over to Network Manager?
Yeah, should we have a look at how do we configure a P1 in such a configuration?
Yeah, let's see. Okay, so hopefully you guys can see my screen there. What we're going to do, this is a file I prepared previously with K2 for the front, Kara for the side hang. I've left it offline because what I want to do is I want to add a P1. So I'm going to go over here, I'm going to add a P1, and there it is. Now the system I've got here in my office is going to use the redundant network mode that we'll talk about a bit later, and that's part of the new version of the software. So let's have a look at that. I'm going to go and set that up before I take it online. I'm going to go down here, I'm going to enable the redundancy, and the one amplifier that I have at home is this one here, and you'll see that it is already in redundant mode. So that is ready for me to take online. Take it online. You can see the two things that I have. Obviously, I've got some AVB not patched. Sorry, some various things not patched there. So what we'll do is we'll have a look at the P1 and we'll have a look at the input panel here, and you can see where you can set up an AVB input, and you can also see where you can, down the bottom here, where you can set up the fallback from AVB to analog and AES, and also from AES to analog and mic in if need be. And while we're here, we'll just quickly point this out. The mic input says the 48 volt phantom power, there's the high pass filter, and there's our attenuation just there, and the generator off there as well. So that's where we set that up. So on this, what we're actually going to do is so I'm setting that up, and we're only using analog in because I've got my phone on an X-Ladder mini jack adapter. And what we'll do is we'll go to the output of this P1, and let's just set up the streams. I'm going to call it P1 front of house 1. And it's the primary, because we remember we've got 2 streams, but when we're in this mode, the 2 streams are identical, and that's how we get our redundancy. So we'll just call that. Okay, so that's our stream. I won't go into all the detail just here, but you can see we've got this time alignment section here right now, and this is the default. The analog and the AES are time aligned, but we haven't time aligned it to AVB because when we do that, it adds a little bit more time. So if you're not using AVB, we make that the default. So what we'll do is click that on to make sure that it is all aligned, analog, AES and AVB now aligned. So now we have that talking AVB. So let's have a look at the LA12X I've got here, and let's look at the input, and we'll click it over here to say we're getting ABCD, the inputs from the AVB. We're going to connect to that screen, that stream that we set up. This here is where I can map the stream. So the A, B, C, and D are the inputs of channels for the amplifier, and these are the channels from the stream that we're using. So I could actually put 8 there if I wanted to, but I'm not. I'm going to leave it as 1. We've set that up. I've actually plugged in the AES already as a fallback, and I've also done analog. So we'll click that in, this is ready to go. We said fallback is on here, fallback is on there. Okay, so we're going to take this online, and you can see I've got it in input mode, and you see there's nothing on the faders there. You can see some stuff on the faders, on the meters here on the P1. And you can see analog inputs 1 and 2 have something on it. That's my mini jack from my phone. So when we open this up, let's see what's going on. So jumping ahead there, we see the inputs there. That's great. We've got a mute there. We've got a ganging thing that we'll talk about later. We can plug in the gain there if we want with a number. And we've got a polarity. So this is the input, and you can see there's 4 analog, 4 AES, 8 AVB, 4 mic ins, the media player, and then the generator at the end. Okay, so we've got these turned on, they're ready to go. The matrix, they're not rooted in the matrix here. So at the top here, we've got the analog in, AES in, AVB in, and these are all the inputs, and those mute buttons act as meters as well. And on the right-hand side, these are all the buses. So this is our matrix. So we're only coming in the analog 1 and 2. So what we're going to do is we're going to patch it like that, and we're going to patch it again, because we've got a left-right and a sub-left-right is what we're aiming for. So we're double patching that. And so now if we look down the end here at the buses, those on-off buttons for the buses also are VUs, and we can see we've got signal. That's pretty good. Now if we jump out, we still don't have anything. So what have we forgotten? Well, if we go to the next tab, by default, the buses, of which Germain said there's 8, they're muted. So let's go in here and unmute those buses. So the buses are unmuted, and you can see all the extra detail in here that you'll get when you add groups and so on of your gain and your delay. But we'll jump ahead to our output, and you'll see, well, let's jump here. We'll see there's 4 signals coming into that amplifier, which is what we wanted. But we'll notice that by default, these are taking bus 5. So this is how you patch the output. But before I do that, let's just show you the top. It's the same mute button. That's the song changing. Same mute button as we had before, the same sort of ganging that we'll talk about, the same gain change that we'll talk about before. But now we're going to add, so we're going to change these outputs here, because this is our fallback. So we've got AVB outs coming from bus 1, 2, 3, and 4. And our first fallback is AES, so that's coming out bus 1, 2, 3, and 4, and it can fall back again if it wants to the analog, which is bus 1, 2, 3, and 4. So that's all ready to go. And as you can see, we do have the signal over here, and you can see it there. You can see we're locked. And that's us all patched. Now, I'll show you some headphone output patch here. Here's the headphone outputs. You can get the different sources here. You can see all the sources, or you can have none. You can see there's a polarity on the outputs there as well. So I think we are ready to go. We have signal. Let's have a look at our mutes. We'll unmute them there, and you'll see that's all good. And okay, so that's showing us setting that up. What have we covered everything there? I think we did all the ins and all the outs.
Yeah, that's great. Thank you, Tony.
Yeah.
No, I think you explained it all pretty well.
Yeah. Yeah, so right now this is all redundant timer lines. So if we go to this LA12X and we go to input and we trigger the fallback, please work. Okay, so let's go back out here. We can still see the signal. And let's go back. So that's showing it in a nutshell of what it will look like. What I might do is show you this ganging now, just so it makes sense when we talk about stuff later. So we've got this ganging feature here, and we've got up to 8 gangs. And on the output tab, we have the same thing, and then another 8 gangs. So the 8 gangs on output are nothing to do with the 8 gangs of the input. You've got up to 16 gangs. So basically what you could do is we could have the first console using all these 4 inputs here, and we could have the second console on this console, on this gang. And now these faders are all ganged. So when I mute that console, it mutes the lot. If I want to change the level, changes the lot. But if I hit the control key, I can make an adjustment if I want to, dependently. So that is how we can do multiple consoles. We can also say there's basically 2 consoles of which we only just get left-right. So we can get left-right of one AES feed with an analog backup, and we can get left-right with another AES feed with analog backup. So 2 different consoles just giving us left-right. And so there's how the gang works. Doesn't have to be contiguous, I think is the word. It doesn't have to be contiguous inputs there. And that's how the ganging works, which is great when you want to have multiple consoles and use just one mute or one fader movement to change one console. So I think we've covered everything there, Germain, if you want to move ahead.
Let's get,
Is there anything, any questions maybe?
I believe so far it's been pretty well answered by most of our moderators, so that's great. We may go through a Q&A section by the end of the presentation anyway, so guys, feel free to reserve some of the great questions that you may have asked, or questions that came several times in a row. All right, so let's go back into our P1 presentation. We should see something else than me. Great. All right, so as you could have guessed a little bit, it's not just a front-end processor, and this was the very first pillar that was pretty much enhanced with the latest capability from the P1. The second large pillar, the second facet of P1 is its audio bridge capability. So take analog from the console or AS from the console and distribute AVB. Take AVB from another AVB talker or from an AVB network and then distribute analog to a self-powered speaker, for instance, or analog or AS to a non-AVB amplifier, for instance, or another device within your system that is not AVB. That's possible as well. So it actually acts as a breakout box, if you will. Take any type of signal inputs and distribute to any type of signal output. But you can do that directly by routing directly the inputs to the output. So it doesn't have to go through the 8 DSP buses that we introduced. You can actually take the direct signals from inputs, analog, AS, or AVB, and send them directly to the outputs. And those will be actually time-aligned as well. P1 makes sure that every single signal, whether it goes through the DSP buses or whether it's directly sent to the output, are time-aligned. So that's a very efficient way of making sure all your system is properly set up. Whether you have non-AVB systems, non-AVB devices within your system, whether you have a couple of self-powered speakers that you brought in. This is going to be maybe the case for our front fields, for instance. Stuff like that. So that's very important. And actually, even from the media player, you could take directly the media player content and send it to any of the outputs of your choice. You could have mono media player file or media players playing mono file and then pushing it into a stereo source to the output of the speaker, playing at 24 bits and 96 kilohertz. Always keeping the 96 kilohertz within our ecosystem from P1 all the way down to the AVB amplified controllers or non-AVB amplified controllers actually as well. But not only P1 acts as a breakout box, but P1 also received the Milan certification. So what does it mean exactly? So we've been talking about AVB. We've been introducing Milan as a term. So those are extremely important terms that you'll be hearing a lot from us in the future and since quite some month, I believe, maybe a couple of years already. But this is kind of almost a new standard for signal distribution, whether it's for audio or control distribution throughout our network. Designing our network designing a full AVB network really helps you increasing the audio quality of your system, but also increasing the reliability of your system with so many different benefits that we'll introduce very shortly and briefly today. But if you do want to know more about AVB and Milan, stay put this week for our webinars, as we will have more thorough presentations and introduction and talks about AVB and Milan. So I'll just briefly cover that. Basically, AVB is the evolution of what we would call the legacy Ethernet. So legacy Ethernet is a protocol that was designed to transmit data but not specifically time-sensitive data. Audio or video, for that matter, are time-sensitive data. It means that we need to receive to properly listen to a content or to ensure true performance, and especially in the case of a live event, we need to make sure that every single audio packet will arrive to our loudspeakers and will be played at exactly the correct time it should be played. This is basically what AVB takes care of. By being an evolution of the Ethernet, it was inherently designed to make sure that you have a true synchronicity of time-sensitive data throughout your entire network. So for all devices that are within the network, it guarantees that you have a on-time delivery of any audio packet. So we're talking about audio packets. It could be video packets, but we're talking about our smaller audio industry, if we could name it this way. But all this AVB Ethernet structure really helps you understanding what's going to happen, when things going to happen, and making sure that that thing is going to happen exactly at the right time. So you're getting onto a deterministic network, which makes sure that your guarantees that your audio is going to be played at the right time. So this is exactly what AVB has been designed for. Milan, on top of that, is the application base. So in terms of network, we have the lower layers, which are the technology or the network layers, and this is AVB Ethernet. So this is the evolution of Ethernet, and on top of that, there is the application layer. This is basically Milan is basically what makes Milan devices understand each other and talk freely between each other. So Milan has been designed by a set of prominent manufacturers within our industry, among which L-Acoustics is part of. And we all agreed on similar terms in terms of audio format, audio stream format, in terms of clocking format, in terms of control as well. How do we control our Milan network, if we can say, but also in terms of redundancy. So it's an open solution that provides certification, making sure that all Milan certified devices can talk to each other and understand. The most important part is really that they understand each other and they talk the same language, if we can say. But one extremely, let's say, a great sidetrack of the AVB and Milan is that it all works in a very plug-and-play environment. Actually, I'm sure, Tony, correct me if I'm wrong, but it took you more time to connect your RJ45 cables to the devices you have at home than to actually set up your AVB network.
It took me a lot more time. It was pretty straight ahead, and this is the first time I've actually set up these LS10s at home in my home network with redundancy. So yeah, very fast.
So it's all made in it's everything is I would not say everything, but most of the things are automatic within an AVB network. So there is things like automatic discovery of AVB devices. So as soon as you plug an AVB device within your AVB network, it will pop up into your command and control and automatically connect to the other ones. Say hello to everyone, and everyone will say hello back, and I understand what you are telling me or what you want to listen to. So all of that gives you a very plug-and-play system. So I could go way more in details into AVB and how does it guarantees true synchronicity, how does it guarantees on-time delivery, but I believe that it's better to leave that for a more in-depth presentation. I believe that's tomorrow, if I'm not mistaken. So how do we see that in terms of signal distribution from P1? Here's the example, very simple example, where we receive an analog signal from the console. We actually have another signal from our USB media player key thumb drive if we want to. And we're sending AVB to a whole set of AVB amplified controllers, like LA12X, LA4X, or the lately comer LA2XI. For very simple networks, we can directly connect P1 to the amplified controllers using the same topology as you've been using with the LNet, so our control network, if we can say. When you connected the network manager to the amplified controllers or to P1 and then to the amplified controllers, you were sending your control on a network that we designed at L-Acoustics, which is called LNet. This is the communication protocol we use. So, and you use RJ45 cables, you use Ethernet cables to connect a network manager to P1, and then you could have daisy-chained, for instance, amplified controllers to P1. Well, for AVB, you have exactly the same topology. So you can do daisy-chain, you can do star topology, or hybrid of the two. This is actually what is shown here on the picture, a hybrid of the two, meaning that for larger networks where you need to have many more amplified controllers, many more AVB amplified controllers, you can have a switch in between the P1 and the amplified controllers, which is Avenue certified, AVB switch, meaning that it has a certification that it can guarantees whatever guarantees the AVB. So it makes sure that you have all the benefits of an AVB network, and you can connect your P1 to the LSN Avenue certified AVB switch, which is our again L-Acoustics AVB switch, and use the star topology to connect a series of AVB amplified controllers, or LRAG2 AVB. And this is exactly what we will do and show you within our use case here. If you want to get a step ahead, take one more step and get into redundancy in AVB, create a redundant network, you can do that very simply by creating two independent networks from the same P1. So we have our P1 at front of house receive the signals from the console. You have two LS10s at front of house. Each of the LS10s received one stream from the P1. So obviously P1 sends identical streams. First primary stream will go to LS10 primary. Second stream, so let's call it the secondary, will go to the second LS10, and that will be distributed in the very same fashion, the very same manner that we'll do with our Ethernet cables. So it's basically really rationalizing cabling when we're deploying a system, and we still have the strength and the robustness of redundancy. It's a seamless redundancy, meaning that on the primary and secondary network approach, whenever something fails or happens on the primary network, it will automatically change to the secondary network, being completely timeline, level aligned, and everything once again, but it will do that without any audible artifacts. So if you're very secured with using a redundant Milan topology, the only thing you have to use as cables within your system are a pair of RJ45s, going from so P1 all the way down to the amplified controllers. Of course, fallback to AES and analog on top of that is even possible. So you could have primary, secondary, and on top of that, even fallback to AES on analog at the input of the amplified controllers. But P1 can also, as an audio bridge, as I was discussing before, you can have receive all your network that you've created in AVB, but for some reason you have used a self-powered speaker as a front fields or monitor somewhere, but you want to integrate those speakers within your control panel, within your control software. So you could even get the control and management of self-powered speaker within LA Network Manager. If you use a P1 to transform AVB signal into analog and connect directly the self-powered speakers to the P1, and then you benefit from the DSP buses and all the equalization, gain, delay. So you can directly integrate those self-powered speakers, like the P series, for instance, within your system. And you can do that directly from LA Network Manager. But you could also have non-AVB amplifiers like the LA8, and you can decide to get the P1 at an LA rack 1 location and distribute AES directly from your AVB network. So it basically acts as a line driver for a self-powered speaker or a converter for a format converter for non-AVB amplifier. So we're keeping the backbone of our system as AVB and distributing for external needs AES or analog. So what does it mean in terms of schematics here? Let's have another look at our schematics, shall we, Tony?
Yep, sounds good.
So we built from the schematics we had before. Let's now add a couple of things. We talked about adding LS10s in a redundant fashion. So we're adding 2 LS10 at front of house, connect that to the P1 sends the 2 independent streams to each LS10s, which are then connected to the LRAC2 AVB. So the LRAC2 AVB actually hosts 2 LS10s directly. This is what differentiates LRAC2 AVB from an LRAC2. It's the addition of those 2 LS10s, which are really made to ensure or to permit the use of a redundant network, a full AVB redundant network throughout the ecosystem of L-Acoustics. And then so we distribute AVB. So we are we're sending from the LS10 AVB to the LRAC2 AVB, distributing daisy chaining the other LRAC2 AVB. From this first, if we can say the first LRAC2 AVB, we're sending cross stage to the other LRAC2 AVB, daisy chaining the one on the stage right. And we're still having our LA rack 1, first of the name, which integrates LA8, which are non-AVB amplified controllers to power our in fields and front fields. And we have another P1 at this specific location that receives AVB in a redundant manner, and that can send AES or analog directly to the LA8s, AES and analog fallback if we want to. We can even think of having a direct fallback from the main P1 at front of house that sends AES or analog to the P1 at stage level, so that we have another step of redundancy here.
Time-aligned redundancy.
Time-aligned redundancy, that's correct. So do you want to add something into your LA Network Manager session?
Well, yeah, I'd like to show a few of the things that you've just pointed out in the session. So let me share my screen. Okay, so what we have, I added another P1, by the way, but let's have a look at the one we're looking before. So I've turned the media player on, which is one of the subjects you were talking about. So I turned the media player on. To do that, I did it from the front panel of the P1. And you'll notice that AVB channels 7 and 8 are now disabled because it takes that power from there to make these happen. So I've got Senior Coconut and his orchestra doing Smoke on the Water on the analog ends, and I've got, of course, some Steely Dan playing on the media player through my USB stick. Cousin Dupree, of course, some Steely Dan, got to have that. So that's how that works. That's pretty straight ahead. The other thing we were talking about, or what you were talking about, is the matrix. So I wanted to point out what we can do when we have a look in here. Now, I've highlighted the P1 up here, and I've gone down and popped this panel up, and we can see I've turned on the matrix. And if I hit that help, if I'm unsure what's going on, can hit that help, and it immediately pops up this into my browser. So this is the onboard help system that comes with LA Network Manager, and it's got a quick shortcut to get you straight to that page to tell you how to set it up. And while we're looking at this and pointing this out, I might just give a quick explanation. So what is happening when we're in this mode is that AVB channels 5 through to 8, so 5, 6, 7, and 8, are used to take the 4 inputs from the top P1 down to the bottom P1, and from the bottom P1 up to the top P1. So that way, each P1 has the 4 inputs it's getting, as in 4 AES inputs with the 4 analog backup, the fallback. They're the 4 inputs that are local to that P1, and then it's got 4 AVB inputs that it's getting from the other P1. So the other P1 has 4 more inputs from a console, AES with analog backup, and it's sending those across to the first P1. So it's a cross-patch thing happening here. Now we have to put it into this special mode, because it's when it's in this special mode, we do a little quick patch internally that you couldn't get to otherwise to time align it. So the AVB cross patch adds a bit of time. So what we have to do is we have to split the signal that's coming in from, say, the AES input on that P1, and we split it off. We send it out the AVB 5 through 8 to the other one. And just after we split it off, we then add some time to it before it goes in the matrix input. And that time, we've figured out exactly what time it needs, so it's lined up with the AVB cross patch. So this is us making sure that your 8x8 matrix is time aligned. When you're using 2 P1s, an 8x8 matrix time aligned. So this is our standard 8x8 matrix, which has the fallback option. So you have AES in and analog in as a backup to your AES. There are other ways of setting up a matrix, even if you just think you've got 1 P1. So 1 P1, you've got 4 analog ins, 4 mic line ins, so 4 more analog ins, and you've got 4 AES ins. Now, you could have one console with 4 outputs feeding into the analog, and another console with 4 outputs feeding into the mic line, and another console, maybe the headliner with AES feeding into the AES. You could do it that way if you want, and just use 1 P1, and now you've got 8 buses, and you can just feed out of that. So there's many ways of setting up a matrix. It all depends on what you're after. So our original 8x8 matrix was all about having backup. So people like to have a fallback. So we have the AES falling back to the analog, which means it eats up those other inputs on that P1, which is why we need 2 P1s to get that 8x8 matrix with full redundancy. So that, let me go back to that. So that's how we see that, how we set it up. And when we look on the matrix, you'll see a big purple 8x8 time alignment on little highlight there to point out to you that you've got that on. You'll also see that or something very similar on the front panel of the P1. Just like, remember way back at the beginning, I switched the time alignment on from the analog and AES to the AVB to add that extra time to make sure they're time aligned. There'll be something in the front panel of the P1 to show that to you as well. So everything you do, you can see there. What else do we have a look at? I think that was there were the things I wanted to point out. As you can see on this panel, while we're here, the media player's coming in there, and I've centered the matrix out to the outputs. And while we're here, I didn't point this out the first time around, but the Q bus is like another DSP bus. It's not exactly like the other DSP buses, but it's pretty darn close. As you can see, we can put some gain in here, or we can put our time in here, and we've got an off on. So there's a lot of control just there, and so it's like another hidden bus almost. We don't call it a bus because it's just a queue. So, but it has a lot of power. So I think we've covered everything on LA Network Manager that you went through before. Is that right?
Yeah, I believe so, and I did it greatly. Thank you, Tony. All right, so we kind of talked about. I believe that's my turn to share my screen. Then
Yeah.
Here we go. So we talked about the two first pillars of P1. So P1, yes, is a front-end processor. P1 is an audio bridge. But P1 is also a multi-microphone measurement platform for system tuning, if you will. So usually what you have in your gear when you want to tune your system, you have a acquisition system. You have external computers for your to run your software for taking measurements or for visualizing and analyzing the measurements. You may have a signal generator somewhere. You may have a media player on the other side listening to your favorite track and assess the performance of your system. Well, actually, P1 and LA Network Manager, so the very same software platform that you use, integrate all that into the same structure. So it replaces all the third-party measurement acquisition tools that you require to set up to tune your system into these same devices, the same front-end processor and audio bridge devices, and communicates with LA Network Manager and M1, which you've had a very thorough webinars about last week. So if ever you need to learn more about M1, feel free to go back to our YouTube webpage and have a watch again on those webinars. But basically, P1 acts as the signal generator. It acts as the sound card. It acts as the acquisition tool. You'll get your measurement microphones plugged in. It will distribute the 48 volt to these phantom power to these measurement microphones. You will have the possibility to listen through the media player, as Tony pointed out, to your system, to your favorite track, maybe the Steely Dan track if you're not too bored about it yet. And you'll be able to tune your system right using P1 and M1 together without any external tool. There's actually quite a cool little use of the temperature and humidity sensor, which is quite convenient if you want to know in real time what are the conditions, what are the atmospheric conditions in your venue, and adjust the response of your system accordingly. So there are quite a lot to say about all this system or the measurement workflow and process, and that has been extremely well explained in the M1 webinars. But I think the best way here is to really show what can be done and what is the P1 how is the P1 acting into this workflow. So Tony, you introduced it. There is a signal generator that you can use from the setup page of LA Network Manager. So it could be the one that generates the sweep that you will use for M1 measurements. But it can also be used to activate a sine wave. It can be used to activate a peak noise if you want to look at specific frequency, exciting frequency in the venue, for instance. It integrates a set of filters, IR filters, and so that you can tune your system even more. It could even be used as a guest EQ layer, if you will, to hand the system to an external sound engineer. It can be used for the auto climate tool, and which is basically a software / M1 P1 tool that according to the current atmospheric condition will propose you a compensation to put on your system to make it sound exactly the same as it was before the change in atmospheric condition. You could welcome your media player to play a track and assess your system, but there is a very new tool that's embedded into that P1 and LA Network Manager, which is the RTA for live monitoring. So you now have the ability to trigger the RTA directly and monitor your system right through the microphones that you've plugged into the mic inputs of your P1. So what do we do, Scott? Do you want to show a bit how does that work in a real test environment. I believe you're in our office in the USA, I believe.
Yeah, let me just grab the screen here real quick, Jamal. Thank you for that. So just a reminder to everybody, we did a series of webinars last week all about the measurement process, system calibration, and tuning. And the P1 is very much the central core of this. As Jamal was saying, often we do a calibration, we have a dedicated piece of software and a dedicated piece of hardware. What we're doing with P1 is really making this part of the ecosystem, and the P1 has those 4 beautiful mic preamps that Tony's been talking about, those mic line inputs on the front. So I've set up a system almost identical to Tony's here that he's got, and just a reminder to you guys, within the P1 we have those 4 mic pre's, we have a generator here, and we can use that generator to, for instance, check our system calibration, make sure that every transducer is working in polarity. If you remember the old school way to check 2 transducers polarity, it's to run, say, pink noise out of 2 adjacent subwoofers and unmute them individually. We can use the P1 to do that. And what this is really nice for, of course, is on a show site or a festival, the P1 is not just a matrix, it's also our EQ bus, and it's also our console to generate that noise. It's also our mic pre's to record the signal. So the full workflow here, just a reminder, we can add what's called a measurement location. So we can plan out our system tuning and calibration, and we can just call this mic 1, and let's add one more location, and let's call this mic 2. And for these 2 locations, we can decide what we wish to acquire data on. In this case, it's going to be house left K2 and left subs, and I can also just duplicate that by touching the 2 together. So our initial setup of our network manager session for system tuning and calibration can be done here. We can enable on the P1 itself to make sure we have the phantom power on. As Tony said as well, we have a high pass filter if needed to clean up the signal a little bit. We can even start by setting our preamp gain, and we can see I happen to have 2 microphones with me right now, and I can see that I'm talking into mic number 1 or mic number 2. So before we get to the show site, we can go ahead and set up and configure our system calibration. And when we get to the tuning page and we open up M1, what you guys also have a choice of is the source of the measurement signal. In other words, what's my patch today? So I could choose that my house left K2 is patched from bus number 1 and that my house left subs is patched from bus number 3. And that would match my configuration I've done of my P1 buses. And as simple as arming and recording. I'm not going to do that today. Once again, go on to YouTube and check out the videos from last week. We're ready to go and do our system calibration and tuning. The P1 is the center of that ecosystem and will handle all the management, the muting, the unmuting, the naming, the labeling, everything you have to do. It's quite seamless and quite easy. The second thing I want to show you guys real quick is P1 comes with a USB, and we can see this in video here, just barely, a USB probe, and this measures the temperature and humidity of the atmospheric conditions where it is, right? So why is that interesting? Well, the atmosphere has one of the largest effects of the system response. So in this setup I have today, I've imported my design from SoundVision, which included atmospheric corrections based on the prediction from SoundVision. So SoundVision thought the weather was going to be something. And what we can do here is enable what's known as autoclimate. And autoclimate is a tool for modifying the system response, and the P1 is helping you do this with this probe. So the P1 is actually measuring atmospheric conditions in my studio here at 21 degrees Celsius, 44% humidity, but my design assumed 60% humidity and 20 degrees Celsius. Doesn't seem like that big of a difference. But what we should probably do is check to see how that change in humidity is going to affect the throw of our system at this particular festival. So I can do that by just clicking on this button here, and that will load the settings of the P1 into the autoclimate calculation. It's actually telling me, by the way, Scott, you should increase the response of the system by this amount. And autoclimate gives me a nice fader to use, which is easy and smooth, so I can slowly transition the system response during the live performance and make sure I'm getting the response as expected. So this will automatically do that for you. You can also manually enter any difference. So say we're out in the desert and it is 15% humidity, and it finds out we need a lot more auto climate, right? So we can even do that. Or it turns out we're doing a show in London in July. Sergey will correct me if I'm wrong, but it's usually about 95% humidity. And it turns out we can turn that down. Is that right, Sergey? 95% humidity in the summer?
Probably 94 to be exact.
Okay. Got it. Thanks, Sergey. So we can adjust that and we can enter those conditions manually, or via the USB temperature and humidity sensor on the P1, we can grab those conditions, and you guys are in control, can choose to make that change as you see fit. So last and not least, mentioned during the middle of the performance, we can monitor the system, and with each version of LA Network Manager 3.0 and above, you have access to an RTA, and this real-time analyzer comes actually in a separate window. There it is. And so that separate window can be moved off your screen, for instance, to a second screen in front of the mixing board. Each of the mics can be calibrated, and once you've actually calibrated those microphone inputs, if you change the sensitivity of a mic, it's not going to change the calibration. It's tracking that plus or minus for you as well. We can monitor dBA, we can monitor dBc, we can set different smoothing rates for each different microphone, and different averaging as well. So this is a really great, powerful feature for this device to all be included into your drive system and use the same software platform that you're already using. So you don't have to get outside of that L-Acoustics workflow to both set up your system for tuning and calibration, acquire that data, index that data, name that data, and then deal with operation of your system from changing climate conditions or monitoring the system response in real time.
That's great, Scott. And
yeah,
you propose to measure the K2 or a K1 or a Kara system, depends on what you have in your system. But I believe we can also do that now, since this very last version of P1, with any other devices that may not be included into our current system. So it could be self-powered speakers like P series. Is that correct?
So I can actually, yeah, exactly. So you can actually both measure the amplified controllers like the LA12X or LA8 or LA4X that you have in your system, but you can also use the P1 bus to say measure those house delay speakers that are at an amphitheater somewhere in the world, or the under balcony speakers, or maybe you're using some 108P as front fill. So those same buses can measure that as well. So here in this case, I can assign this measurement location to both buses that control amplified controllers and buses that control the P1 itself, or groups that control the P1 itself, pardon me.
Okay, great. So if I have a hybrid system of powered and non-powered speakers, then I can actually do everything through LA Network Manager and P1, whether it's for calibration, whether it's for tuning, whether it's for control monitoring and all of that. So that's awesome.
Exactly. That's exactly it.
All right. Thank you very much, Scott, for sharing all these great information. So we'll wrap up this presentation with a very short presentation of typical applications we could use P1 in, and I'll let Tony handle this section. Tony, do you want to have a look at and explain a bit what we can do with that P1?
Yeah, absolutely. But
typical applications.
Before I do, I just realized that there's 2 or 3 things I just wanted to quickly point out in Network Manager, a couple of really obvious ones that I probably missed. So can we just pop that up there first? Okay, so we should be getting that back now. Okay, so the simplest thing that I forgot to show everybody that might have never used a P1 before with Network Manager is that these blue groups are groups. So we can add a group and it is black like it's always been, and we can name it like we usually do. EQ for that one, and it's empty now. But as soon as we add a P1 to it, it turns blue. So that's the difference between a P1 group and a normal speaker group. So that's one thing I just quickly wanted to point out. And the other thing is just to clarify an output patch thing. So just a way of looking at this is an input tab here. If you think of across the top here, they're like input connectors, yeah? And so it's the same way you want to look at the output. These are output connectors. So if the output connector, you wanted to use analog outputs 1 and 2 to get the Q bus, you go down to the bottom here and you say you want to come from the Q bus. So now it's using those analog connectors to send the Q bus out. So just wanted to make that a little bit more obvious for everybody. So if you look along the top here, it's almost like they're the connectors. Yeah, headphones is a connector. So that's how we do the Q out if we wanted to. So that's just a few little things I wanted to point out on that, but we can go back to the PowerPoint if you want.
All right. Here we go. This is what you should see, guys. So we'll start with a very simple type of application to understand that P1 can also be used in the very simplest manner. Okay. Do you want to jump into it?
I will. Yeah, no, I can't see it full screen here, so I'm just jumping over here to try and see it. Okay, so the first one is pretty much along the lines of what we were looking at before for the system that we put together. Okay, I can see it now. Sorry, there we are. Okay, I've got it on the full screen. So, okay, this is the most basic system we can put together with the P1 and AVB. So, one console, one P1, 4 amplifiers. It could be LA4Xs there, some Kiva, some subs, 15s and 18s, and it's a small gig. So this small gig would just use some short multi-cores from front of house to stage. So the network cable might be, 50 meters, 60 meters, maybe 70, easy. Just a network cable to join the P1 that's at front of house to the amplifiers at stage. So front of house, you've got a P1 with 2 network connectors on the back of it. So you could plug your laptop into one connector, and from the other connector, you could run your 50-meter cable, Cat5, Cat6 cable, your network cable, down to the first amplifier on stage left. And then you daisy chain to the next stage left amplifier, and then you do a cross-stage network cable, and then daisy chain those two. So basically, that's the simplest setup with AVB and a P1 you can have. There's no network switch in there. It's just basic. It doesn't use fiber or anything fancy like that. It's just a nice, small, compact system that still uses AVB.
Actually, by just connecting the amplified controllers to P1 in AVB by itself creates an AVB network.
Exactly. That's all you need. It creates the AVB network. And I love this system. This is such an easy way of getting on board with AVB. There's huge benefits of AVB, and we can talk about it a lot, and there's webinars to describe it all to try and let everybody know all the little details. But the bottom line is your ears. And if you plug this system in and fall back to AES or analog, you realize that the AVB sounds superior. So that's my take on that one. Anything from you on that one?
No, I think you pretty much covered everything. It's the main reason here is to really point out that it could be from a small system such as this one, all the way to a much larger system such as the one that we see on the screen here, that we've deployed throughout our conversation here, where we have quite a lot more gear. But in terms of network and connecting AVB, all devices in AVB, it's almost as simple as we've seen in the previous slides. Basically, just putting in switches in between all the setup. We could even get into more complex situation in a bit about what you described a bit earlier when you explained the cross patch to create an end-by-end matrix, even if you still desire to use the redundant mode today, I guess at least since the new version of P1.
Yes, exactly. So, and this flow chart here shows exactly the matrix I was talking about. We have 2 consoles, each sending 4 signals with an analog an AES signal with an analog backup, a fallback. So we have that redundancy in place. And people wonder about the redundancy and, if it's necessary, and that can be debated till the cows come home. But the thing is that when you're setting up for a festival, what you try and do is cater for everybody coming in. So you don't really want to go in and play with your matrix all the time. You just want to have it configured ready to go. So someone can turn up with a digital console and they can plug the AES in and give you some analog backup, or if they don't want to give you analog backup, they don't have to. Or I've had someone turn up with a digital console and say, I'm just going to give you analog. So when you plug that analog in, you want it to work. You don't want to have to repatch something or unmute something or push a fader up or whatever. You just want it to work. And if you're not plugging the AES in, it automatically falls over to the analog. So now it works. So that's the way I've always set up the system, with AES input and analog fallback. So no matter who comes along with whatever console, you just say plug into those holes there, and you can give me either or both, and it works without me fiddling around with the matrix, which could cause an error. So this is the I think a really good way, and the way that a lot of people use to set up their matrix. So in this one here, is exactly what I described before. 2 consoles, 4 signals, and we've got them listed up there: left, right, sub, left, and right. And then they're getting 8x8 matrix created by the 2 P1s with a cross patch of AVB between them. And then we're sending them down to stage to distribute the signal.
The very same fashion as we did before. And that seems pretty much way easier than what we used to do with all the multi-cores of cable and in AES or analog.
Yes, absolutely. And I mean,
it does look at least simpler.
I would say to people, you should have a backup. Going from front of house to stage, you should always have a backup. You've got a system that large, always have some sort of backup, a fallback with an analog is perfectly fine. Analog will sound just great, because it is a fallback that hopefully you'll never ever use. But if you have to use it, it'll still sound good. Where if you go AES at a certain point in time, you've got to watch your cable length. So a short cable, AES cable, might be fine, but there's different types of AES cable. There's stuff that'll take 96K and stuff that'll take 48K a lot better. So when it comes to cable length, you've got to be careful. But with analog, if you've got good analog cable like everybody's had for decades, then it'll work. So analog is perfectly acceptable for your fallback to get from front of house to the amps on stage.
That's great. I think you pretty much covered all the topics we wanted to approach. There's been many questions and many great answers by moderators. Thank you, everyone, for joining us today. Thank you very much, Tony, for helping me out with this great presentation. Thank you, Scott.
Thank you.
And thank you all the guys around the world that managed to answer as many questions that they could. This is not an easy task because there are so many questions in real time. So really appreciate your help.
Thank you.
Any closing words, Tony or Scott, or any guys from around
just
the
my
world?
reminder to everyone, this week we've got a series of webinars about P1, about drive systems, about AVB networks. I think I saw a lot of questions in the Q&A about different topics that associated with all of these things. So please don't hesitate to join us. Tomorrow we're actually doing a presentation about the drive system as a whole. Wednesday, we've got a really amazing individual. Nick Payne is going to present his sound design for Rammstein, which includes a really significant AVB network. And on Thursday, Etienne Courtel and Gagno Kroner are going to present a presentation all about why, how, and what AVB. So it's a really great presentation to really dig deep into AVB as a big topic. So I just want to remind everyone of that. So please don't hesitate to come back.
Once again, thank you everyone for joining. Have a great rest of the day or night for some of you even. We notice people connecting from Asia, or from Australia, so must be a late night for you guys. Thanks for listening to us and joining us today, and see you next time. Bye-bye.